Frictional phenomena. Type of friction. In this article, we briefly discuss the type of friction resistance encountered in machines. The next article contains a more detailed account of the most common type of friction. The first type of friction is drive friction. Drive friction occurs when the unlubricated surface of two solids are in contact. Under a condition of sliding or a tendency to slide. A friction force tangent to the surface of contact occurs both during the interval leading up the impending slippage and while slippage takes place. The direction of this friction force always opposed to the motion of implementing motion. The direction of this force always opposed the motion or impending motion. This type of friction is called the Coulomb friction. Coulomb friction, drive friction. The principle of dry or Coulomb friction were developed largely from the experiment of Coulomb in 1781 and from the work of Morin from 1831-1834. Although we don't yet have a comprehensive theory of dry friction, we describe an analytical model sufficient to handle the vast majority of problems involving dry friction. This model forms the basis for most of the problems in this chapter. The next type of friction is the fluid friction. B. Fluid friction occurs when adjacent layer in a fluid, liquid or gas, are moving at different velocity. This motion causes frictional force between fluid elements. And these forces depend on the relative velocity between layers. When there is no relative velocity, there is no fluid friction. Fluid friction depends not only on the velocity gradient within the fluid but also on the viscosity of the fluid, which is a measure of its resistance to shearing acting between fluid layers. Fluid friction is treated in the study of fluid mechanics and will not be discussed further in this book. The next type of friction is the internal friction. Internal friction occurs in all solid materials which are subjected to cyclical loading. For highly elastic materials, the recovery from deformation occurs with very little loss of energy due to the internal energy. For highly elastic materials, the recovery from deformation occurs with very little loss of energy due to internal friction. For materials which have low limits of elasticity and which undergo appreciable plastic deformation during loading, a considerable amount of internal friction may be accompany this deformation. For the high plasticity materials, deformation during loading, a considerable amount of internal friction a considerable amount of internal friction may be accompany this deformation. Accurate. The mechanism of internal friction is associated with the action of shear deformation, which is discussed in referencing on material science. Because this book deals primarily with the external effects of forces, we will not discuss internal friction further. Dry friction will be discussed in the static, mainly, and other type of friction will be discussed in the related references.